All right, so this will be how to calculate the osmosis, the movement of water in a system. So when you get the test, the questions will look very similar to this, where you'll have a beaker with a side A and a side B. On side A, you'll have the amount of solute and the amount of water. Same thing for side B. Okay, so for this one, we're just going to do this in steps. Calculate the percent of solute on one side of the membrane. That's what you do first. So that's step one. I like to start with the side that has the larger amount of solute. So for example, B has 80 grams, A has 20 grams. I'm going to calculate the amount of solute, or what the percent of all the solute in the whole system is on side B. So 80, which is the amount of solute inside B, divided by 100, which is the amount of solute in the whole system. So 20 plus 80, where we get the 100. And that's 0.80. So 0.80 is 80%. So 80% of all the solute is on side B. If 80% of the solute is over here, that means 80% of the water needs to be over here for this to be in equilibrium. So the next step is calculate the amount of water that's going to be needed on side B. So the water in the whole system is 200 grams because there's 80 on A, 120 on B. So 0.80, 80% of 200 is 160 grams of water that need to be on side B. So side B needs 160 grams of water. It already has 120. So step 3 is where we're going to calculate how much water needs to move. All right. If we need 160 over here and there's already 120, that means 40 have to move. So 40 grams of water move from side A to side B. We have a way of checking this. We can check our work if we want to. And when we check the work, we're actually calculating the concentration or the tonicity of each side. To do this, we're going to take the amount of solute on one side and divide it by the total amount of stuff. So the total amount of water and solute. So for side A, we have 20 grams of solute. There are 60 grams of total material on side A, because 20 plus 40 is 60. So that comes out to 0.3334. When we times that times 100, we can see that side A has 33% solute, or its tonicity is 33%. Side B has 80 grams of solute, but there's 240 grams of total material. So 80 divided by 240 is still 0.3334 times 100. So side B has 33% solute also. So these, side A and side B, are now in equilibrium.